Okay, I think we're on. Thanks for hanging in here. End of the day on Friday. We've heard a lot about serverless over the last few days, mostly about functions as a service, and there's a lot of excitement around functions. And I'm certainly super excited about functions. But today, I'm going to fold in another important piece of the puzzle, which is around serverless APIs, which combined with serverless compute, allow developers to keep pace with a very fast-changing business world and technical landscape. In this talk, I'm going to dive into some real-world use cases that highlight patterns that I've been seeing with serverless and what works and doesn't work so well. First, what's serverless? I spent a bunch of time with the CNCF Serverless Working Group where we talked a lot about this term that has now become a bit of a buzzword. And it really boils down to a few things, which is, this is just your code. You can focus on building, deploying, running your application without provisioning servers, without worrying about VMs. And it scales up according to traffic and scales back down again when you don't need it, and you only pay for what you use. When people talk about serverless around here, mostly we're talking about serverless compute. Lambda was released in 2014. IBM, which you just heard about, released OpenWhisk as open source software in 2016, and later the hosted version of IBM Cloud Functions. We've got Azure Functions and Google Cloud Functions. I think Google App Engine also meets the definition of serverless. It was launched in 2008, I think before serverless was a term. It auto-scales up as you need it and scales back down to 0 when you're not using it. This early serverless contender enabled the spectacular launch of Pokemon Go and also powers Snapchat today. But what's driving all this serverless excitement? I would argue that it's the growth of APIs. This is a chart of the growth of business values delivered through APIs, which the programmable web has been tracking since 2006. Developers today just expect that they can connect to data enrichment services with thousands of lookups, often just costing pennies. And there's a wide array of transactional APIs that you can use for payment and e-commerce. Pretty much anything you want to do that has been done a lot of times, you can find an API and just pay for usage. Most of these APIs I would call serverless. They auto-scale up and down. You don't need to manage servers, and you only pay for what you use. Here are some APIs that are the ones that are used in the use cases that I picked. I want to go through these just so that, since you may not recognize all the logos on the chart, and you're familiar with them when you come across them. In the top row, there's Google Cloud Storage and Amazon S3, which are kind of the original serverless APIs where you can upload an incredible amount of data and download files or blobs, and it scales magically in the background, and the cloud providers do all the work to manage large amounts of infrastructure. Then there's PubSub and Publish Subscribe, Google Cloud PubSub and Amazon SNS, which allow you to often stitch these things together. So you can publish a message on a topic and receive it, and somebody else can receive it, often a different part of your infrastructure or your serverless application. Also featured in this talk are Cloud Datastore, which is a beloved NoSQL data store, which allows you to build an application where the performance of that application scales with the size of the result set, not the amount of data that's in the system. So you can build something small and expect that as your app scales with number of users and with amount of data, your performance will be the same. The next generation of this is Google Cloud Firestore, which combines with the Firebase SDK to allow real-time data updates to the client and has the same properties of Cloud Datastore. And then we've got Google BigQuery, which is used for big data analytics, and Google Cloud Vision, which is one of the many Google Cloud machine learning APIs. And then there's a number of other APIs. There's Stripe, which is used for payment, the Magneto API, which is used for e-commerce, and Lucky Seat, which is used to pick winners in a lottery. So I'm going to go through 6 serverless patterns. And in choosing these case studies, I tried to find examples that showcase the most common patterns that I'm seeing in real-world applications, and places where I see that developers are seeing the most success with serverless. So the first pattern, the most common one in terms of usage of functions, in terms of the number of functions executed, are data pipelines, or the extract, transform, load pattern. So typically, a log file will be uploaded to an S3 or Google Cloud Storage bucket. That will trigger a function which does some processing and then stores the result in a database. Often these are long pipelines that do many things, that call machine learning APIs or APIs to find out more data or validate the data that's being sent through. Then the next most common use case is notifications. So classically, you would need to stand up a server and poll for changes if you want to see that something changed in a particular query. Now instead, you can just listen for that change and have a function triggered. Of course, it doesn't have to be a data storage query. It could be any API where a state change, maybe it's done doing a time-intensive task, maybe it notices something different in the world that triggers a function. Compared with traditional API construction, we can think of it as registering a query with a callback that is notified when there's something new in the result set, or when there's something that was deleted, or when one of the results changed. And it changes how you construct your code, and it dramatically simplifies these kinds of notifications. Of course, you can also just do notifications via email or SMS, text, or what have you. Very closely related to notifications are real-time updates. Illustrated here is Firestore, which does a lot of the heavy lifting for you, combined with the Firebase SDK, so that you can listen for events on the client and write a serverless app that just runs in your browser, your mobile app, and reflects changes to the user. But people are doing this same pattern, wiring it all together with custom code, and you can see a lot of examples of that out in the world. The next pattern is content management. So this is probably the most commonly used example of the make thumbnail, where you upload a big image and that triggers a function which then resizes the image and stores a small version of it in a database. Then client access is something that I don't hear talked about, but I see used incredibly frequently. So there's a number of different serverless authentication systems. Probably there are many more that I don't have direct experience with. But in this case, what you're doing is a mobile app or web app will call this authentication system and allow the user to log in, and then subsequently the user has a token that can be easily validated on the server side, and that token is passed to a function. The function can validate that the user is whoever they think it should be, and then the function holds the key to the API. And this is very important because you can't have your API keys that bill you for a certain number of API transactions out there in the wild. So this same client access pattern is built into Firestore, and then there's Firebase rules on the server side, which lets you declare what parts can be accessed. And that's, we're working very closely with OPA, so you can do that same type of pattern in the open source using OPA. One pattern that kind of surprised me to see so frequently is live data migration, although once I started hearing about it, of course, it's a great use of serverless. So in this case, you have, of course, your Datastore you're migrating from needs to support events, but during your migration, you can have no downtime because a write to the Datastore triggers a function, then you write to the new place. And then, and that's my list of 6 common serverless patterns. And what I'm going to do next is dive into 4 use cases from a wide range of domains using different technologies where you can see these patterns at work. The first one is Hawkins Dynamics. So these are, Hawkins Dynamics is a sports science company focused on providing cutting-edge hardware and software systems for measuring and assessing athletic performance and potential. So these force plates are these big plates on the ground, right? And you're an athlete, and you put one foot on each plate, and you jump, and when you land, it detects the force of your landing, and it then conveys all of that to give you visibility into how you were jumping and your athletic performance, or to your coach. So I'll dive into how this works. So these force plates are connected wirelessly to an Android app, and they send the data to the Android app, and then the Android app, and that's great because it works offline. You don't have to be connected to the wider internet. And the force plates and the Android app work together. And then when the Android app is online, it authenticates to Firestore with Firebase Auth and then sends data to Firestore. And then the coach, no matter where they are in the world, can view the athletic performance that's happening right now in real time or over time. And the athlete or their coach can view the performance data. And this is an incredible example of serverless at work. And it was only when I dug into this particular case study and was talking to the developer that I learned that they had a live migration that they had done using Google Cloud Functions as well. So they previously had been on the Firebase real-time database. And so what they did when they wanted to migrate to Firestore is they added a Google Cloud function so that every time the Android app wrote to the real-time database, it would write to, it would trigger the function and then write to Firestore. And this allowed them to roll out a new version of the Android app that talked to Firestore, and then once all of their users had been upgraded, they could shut down the real-time database and remove the cloud function, and then they've done the whole migration with no disruption in service. And it's a lovely story, and I've seen that type of use case replicated by a lot of companies, and it's really a nice use of serverless. The second case study, very different domain. The Hamilton musical is very popular in the United States. So this is a musical about US history, and they built a mobile app for the musical, and a mobile app that's for musical is not the product, right? The product is the musical. So the mobile app really needs to be delivered at relatively low cost and be operated by non-technical folks whose primary job is theater, not mobile apps. The app was developed by Posse, a digital agency that used serverless to stay focused on the app and their users. And I'll go through a few parts of 3 different parts of the app where they use serverless. The first is for the lottery. So this very, very popular musical has been going to different cities in the United States, and it is always sold out. One of the things they do that is really lovely is they reserve a number of VIP seats for just $10. So when this was in San Francisco, like 100,000 people would enter this lottery every day. And my friend entered the lottery every day for 4 months, and then we actually were able to see Hamilton 3 days before it closed. It was amazing. So you can imagine this is a lot of spiky traffic, perfect use case for serverless. So how does that work exactly? So the mobile app authenticates with Firebase authentication that also saves the profile data to the real-time database. And then people can sign up for the lottery, I think, after 4 p.m. the previous day or something. And then on a timer, on a cron job with App Engine cron, I think every morning at 9 a.m., they call out to Lucky Seat, which is an API specifically built to fairly randomize the winning ticket. And then the real-time database, that winning ticket is written to the real-time database, which notifies the client. The second use case, the second part of the app is really a content management system. Until I ran my own mobile development company several years ago, I never realized that major TV shows and theater productions usually have their own mobile app. It's a thing. So the app needs a way for the operator on the back end to provide content. And typically, this is somebody in the entertainment industry who's fairly technical, but not a programmer. So, the admin web app allows for uploading images to Google Cloud Storage, and then that triggers a function which then can size the images for all the different mobile devices, write them back to Google Cloud Storage, also write metadata to the real-time database, and that sync to the app. Pretty straightforward. And then the last use case is merchandising. So it's typical for a mobile developer. They don't need to build a whole e-commerce catalog. In this case, they used the Magento API, and then they use Stripe for payments, and having a function in between allows them to keep their keys on the server side. My third use case is Guesswork, which is a machine learning startup that helps e-commerce companies in emerging markets recommend products for first-time buyers on their site. When a new user arrives at the site, Guesswork analyzes a lot of data points: where a new user is coming from, such as an email campaign for t-shirts or a fashion blog about shoes, as well as device type and geography. And from all that data comes up with a recommendation. So let's dive in. This is a specific use case where they worked with Zalora in Southeast Asia to bring better e-commerce recommendations to their customers. So the person comes to the website and for their e-commerce visit. Through the Google Tag Manager, which embeds the Firestore SDK, it writes information about the visit to Firestore, and that triggers a couple of data pipelines. So first, a Google Cloud function triggered off the right stores the data in BigQuery that's then available to the recommendation engine to query. Another Google Cloud function uses the Vision API. And this is really interesting. What they found was that because they served so many different languages, the metadata that was text about the product wasn't that reliable to find good product info. So they actually use the image of the product to analyze metadata about the product and feed that into their recommendation engine. And then they can do real-time notifications to the client for anonymous users, and then for registered users, they can periodically send email. So this is the whole picture together, and this architecture made it easier to make changes, which allowed them to easily set up A/B testing, which significantly increased the quality of their recommendations and their revenue. So with serverless, Guesswork bootstrapped their company, grew a business that now serves 100 million users with just 3 developers. The last one, which is my favorite story, is Semios, which provides 24/7 monitoring of your orchard. So this is the Semios gateway standing in the orchard, and you can't see in the trees. There are devices hanging in the trees which collect data and send them to the gateway. And there's also ways that the gateway can communicate back and control the pest population or control irrigation. And then the gateway talks to the cloud. In this case, periodically the gateway uploads its logs of IoT data and images to S3. And then S3, when it gets new data, triggers an SNS, sends a message on an SNS topic, which hops over to Google Cloud and adds the message to a pub/sub topic, which triggers a cloud function, which then writes to Cloud Datastore. Then Elastic Beanstalk runs their traditional web app and gets the data out of Cloud Datastore and presents the data to the farmer who runs the orchard, who can then act on that data. It was surprising to me how some developers so easily mix and match services across clouds. In this case, Semios was using AWS for their whole backend infrastructure, but they really loved Cloud Datastore, so they hooked it up with serverless. And we're seeing more and more that it's not that people are wed to a single cloud. They're mixing and matching great products together. And this makes sense when you reflect on the fact that they're using a lot of different APIs and that no cloud provider offers all the APIs they need anyhow. So these are my 6 serverless patterns that I came up with. But this is only part of the story. There are also some pain points that I wanted to share with you. Some people are saying that serverless is zero ops, but I feel a little conflicted about that. It certainly reduces your ops burden. We don't have to manage servers and VMs anymore, and that's great. But even if you're not managing servers, you still have a kind of ops. You have to make sure your app works. And I've been hearing people talk about this as app ops. I don't know if that word's going to stick. But how do you know your app's working in production? What do you do when it fails? You still have to worry about these things. One of the key challenges is observability. You need to pay attention to when your services are failing. And with serverless, you typically have many small functions connected via events. An end user might observe a failure many hops away from the root cause. When we build apps with serverless, we're actually building a distributed system. And those of you who've built infrastructure, who are coming from a world of this is easier because I'm not managing my whole cluster, you're familiar with what you might need to do to hook this up. We also have a lot of application developers that are coming from client-side development, where this is a whole new world. And I think as service providers, we all have to think about how do we give people these tools to make this easier. But to some degree, it's about what your app does. What are the signals that you need to make sure your app works? So we need to be thoughtful about logging, setting up monitoring and alerting. And it doesn't come for free. Then what happens when something goes wrong? You have to debug it. Things are different when your VM is there, has a problem, and scales down to 0. You have to debug it differently. You can't use the same tricks that maybe you did when you just ran VMs yourself. With every serverless platform right now, you have to do a bit of experimentation to get your workflow down. There's a lot of activity in this space, and I expect things will get better, but it's a bit wild west right now. And then security. Security is different, sort of. With a cloud-native microservices architecture, your security boundary is going to be a bit different. But You need to be thoughtful about key management. But remember, the exact same security issues you've always had, you still have. So serverless does reduce your ops burden, but it doesn't go away. You're still responsible for making sure your app works. So sometimes servers can be nice. Like, serverless isn't for all things. If you have a long-lived job, if you have sustained throughput, sometimes it's cheaper and easier to just manage your VMs. If you already have an ops team, maybe, that's fine. VMs can be nice. So, in summary, there's a lot of patterns that are emerging that I think are really exciting, that we're starting to see how these things fit together and what serverless is really good for. What we're seeing over and over again is that serverless enables developer velocity and flexibility. The key value that I've seen over and over again is delivering business value with fast time to market. With serverless, even though right now it might be a little painful, delivering business value 3 months early because you didn't have to build the infrastructure you would normally build can make a dramatic difference in the solution that you're providing and can make a big change to your business. So now I'd like to open the floor for some questions. Yes?
How is Firebase real-time database and cloud-based?
Oh, the question was about Firebase real-time database versus Cloud Firestore. So Firebase real-time database is the original Firebase product that's vertically scalable. It scales really high, but there's a limit. And, but it's very, very good for incredibly high throughput, low latency interactions. So if you're doing like a shared whiteboard, Firebase real-time database is for you. Cloud Firestore has global scale and has all the properties of Cloud Datastore. And so it's the logical successor while also not handling some key use cases of the real-time database. So they've each got their niche. Other questions? Yes? So the question was about Cloudflare, which I've heard of this, but I haven't used it myself, where they allow you to put a function at the edge so that you can have a little bit of logic before rendering whatever's being accessed. And so it doesn't fit into my 6 patterns. And I'm not saying that these 6 patterns are all the patterns. These are just the most common ones that I've seen. And I'm involved with Google Cloud Functions and Firebase and a number of cloud products that are focused on application development. So I may be seeing just one swath of serverless. Yeah, I think that a lot of patterns are still yet to emerge. Yes? The evolution of deployment in zero ops. Well, I think that CI/CD is being embraced by the industry, continuous integration and continuous deployment, and really what I've seen successful in that space is that people have very good monitoring and alerting, because automated testing is great. I don't feel safe without it. But in your test environment, you can only test so many things. And what you really want to know is that when you roll out, what's the health of the system after that rollout? And be very quickly alerted to that. And so, so I think that we're already starting to see a lot of evolution in this space and a lot of new tools in this space of how do we detect the health of a system. And everything from, and we're going beyond, like, traditionally, 10 years ago, my teams were thinking about, like, the RAM, was the system out of RAM? Is this getting hot in CPU? And now we're seeing people looking at business metrics and really thinking about, like, is this working, right? Is my app still delivering value? Because my machines could be running fine, but it no longer functions in the way that it intended to. So I think that type of application monitoring, we're going to see much more sophistication around. Another question? Back there? Wait, so the question is, how long should functions run? Well, I think that all the different cloud providers have limits to how long their functions run, and I know that's a pain point for some folks, and I think that we'll sort of see how that plays out in the industry in terms of, does it must it be a short-lived job for it to live in this serverless world? Like, in reality, every function framework in the world is 9 minutes? Oh, I didn't realize it was a Google-specific question. 9 minutes for Google. Is there another question? I don't know where we are on time. Yes? So yeah, the question was why are our users using one cloud provider over another? Why use Google Cloud Functions or AWS Lambda? And and there's some feature differences, but primarily what I'm seeing is that there's some folks that some of the big companies want to have multiple cloud providers for redundancy, but most commonly there's a particular product that they love on one cloud provider and another product that they love on a different cloud provider. And they just use those two things just the way, like, well, I might use Stripe for payments. That doesn't mean that I'm, like, unloyal to Google Cloud Platform. that they're not seeing the platforms as I must use all of these things in one category. And some of the things, like a lot of the reasons we see people using Google Cloud is because of the wide array of ML options. And so people will use functions along with the set of products that are vented that they really like. Another question? All right. Well, I'll be around afterwards. Thank you very much.